Today we are starting chapter 5.1, and the title of the chapter is Patterns with Decimals. Your learning goal for today that you have written down in your math notebook is to find patterns in quotients when dividing by powers of 10. So let's break that down a little bit. It says you're going to find patterns, you're going to be looking for patterns in quotients. What are quotients again with a silent hand? What are quotients, Liam?
The answer to division problems.
Oh, so we're going to be looking at the answer to division problems, and we're going to be finding patterns in them when we divide by powers of 10. What are some numbers that are powers of 10? What does it mean about power? When we talk about powers, what are we talking about? Rashika? Like 4 to the 10th power? Okay. But we're doing powers of 10. So what's our base number always going to be? Siddharth?
It's always going to be 10.
10. So if our base number is always 10, what is the powers part? Arushi?
It's like the little small numbers at the top.
The small numbers at the top over here. What do we call those small numbers at the top? What do we call those? Yarden? Exponents. So we might have a 1 here, or we might have 10 to the power of 2, right? What is 10 to the power of 1? Just while we're talking about it. Adriana?
I'm not sure, but I think it's 100.
10 to the power of 1 means 10 multiplied one
10,
time,
10.
which is 10. 10 to the power of 2 is the same thing as 10 times 10, right? Multiplied 2 times because the exponent is 2, which is equal to, Claire? 100, yeah. So we're going to be dividing by these numbers that are powers of 10. So will we be dividing by 10? Maybe. Will we be dividing by 100? Sure. Will we be dividing by 30? How do you know we won't be in this chapter? We're not dealing with dividing by 30. Rashika? Yeah, in chapter 5.1, we are only dividing by powers of 10. Is 30 a power of 10? No. Okay, so we're just going to be dealing with numbers like 10, 100, 1,000, 10,000, a million maybe. Okay, very good. It says, the Healthy Wheat Bakery uses 560 pounds of flour to make 1,000 loaves of bread. Okay. Each loaf contains the same amount of flour, right? Of course, to make each loaf of bread, you need the same amount of flour. How many pounds of flour does the bakery use in each loaf of bread? Okay, I see words. I see a math problem. Jason, what's the first thing we need to do? Yeah, and what is the question asking here? Yeah, how many pounds of flour does the bakery use in each loaf of bread? Now, if you are taking good notes, you do not need to copy down the math problem. You don't even need to write down what the question is asking. You can just wait until we get to the equation part, okay? But you need to be thinking. All right, Jason has told us the question is asking how many pounds of flour are in each loaf of bread. What's step 2? What do we need to do next? Karan? All right, what is the important information here? What does 560 mean? Oh, so they need 560 pounds of flour to make what? 1,000 loaves of bread. And we're trying to figure out how many pounds of flour are in one loaf. Okay, in each loaf. Very good. So then we have to ask ourselves, do we do addition, subtraction, multiplication, or division in order to figure this problem out? Misaki? Yeah, and what would be the division equation? And this is where you start taking notes. What is the division equation we do to solve this problem, Misaki? 1,000 divided by 560? Is that what we would do? We got to switch them around, right? Because we have 560 pounds of flour altogether. We want to switch this around because we have 560 pounds of flour altogether, and that makes 1,000 loaves. So if I divide it by the 1,000 loaves, that'll tell me how much flour is needed for each loaf of bread. We haven't talked about division in a couple chapters, so let's remind ourselves. What is this part called? The first number that you are dividing into different sections. What is that part called? Daniel? Dividend, yep. And what is this part called, the number that you are dividing by? Harshita? Divisor. And what is the answer called, Adam?
Quotient.
Quotient. Okay, remember there was always a question I would ask you guys whenever we did division. I would say, is this a grouping division problem or a sharing division problem? Let's look at this. We know we have 560 pounds of flour all together, and I need to share it amongst 1,000 loaves of bread. So is this a grouping division problem or a sharing division problem? Zara? Yeah, sharing. Okay, and I just told you why. Very good. You can use what you know about powers of 10 to help you find quotients, to help you solve division problems. Okay? And I want you to write this part down. This is very important. Dividing by a power of 10, just write word for word. Dividing by a power of 10 is the same thing as multiplying by 1/10th, 100th, or 1,000th. Okay? Go ahead and write that down. When you multiply 560 times 100th, how does the decimal point move? Rashika?
2 spaces to the
Yeah, when you multiply by 100th, you multiply 2 spaces to the left. That is the same thing. Multiplying by 100th is equal to dividing by 100. You'll notice when you divide by 100, you also move 2 spaces to the left, the decimal point. Finally, when you multiply by 1,000th, how does that affect the decimal point? When you multiply a number by 1,000th, how does that affect the decimal point? Well, as you can see in the chart, it moves 3 spaces to the left. Multiplying by 1,000th is the same thing as dividing by 1,000. Okay? What patterns do you notice here? Looking at this chart, what patterns do you notice? Adriana?
that each time we multiply, like, for example, each time we multiply by, like, a 10, each time we multiply a 10 in the multiplication, a 10 less,
Mm-hmm.
and in the division, a 10 more,
Yeah.
you get the same answer.
Our equation to find out the answer to the problem was 560 pounds of flour divided by 1,000, right? And I know that dividing by 1,000 is the same as multiplying by, as Siddharth said, 1,000th. So I can rewrite this problem as 560 times 1,000th. I also know, because I was really good at chapter 4 in multiplying decimals, I also know that when I multiply by 1,000th, how do I need to move the decimal point? How do I need to move the decimal point? Liam?
3 spaces to the left.
Okay, so originally my decimal point was right here. I need to move it 1, 2, 3 spaces to the left. So, how many pounds of flour does the bakery use in each loaf of bread? Adam?
5,600.
Yeah, so the answer is 5,600 pounds of flour. Okay. Another way we could look at this problem is by using what we know about exponents. Okay, so you have the same problem right here, and I love those of you who are taking good notes and writing this down. You have the same problem, 560 divided by 10 to the third power. How is that the same problem? It looks different to me. Why are they saying that that's the same problem? Yanming, why is 560 divided by 10 to the third power the same as 560 divided by 1,000?
Because like 10 to the third power is 1,000.
Why? 10 to the third power is what?
There's 10 to the third power is 10 times 10 times 10.
Ah, which is 1,000, right? Very good. So would you guys agree that that's the same problem? Okay, so let's look for a pattern. 560 divided by 10 to the 0 power. Anything to the 0th power is what? We know already. Anything to the 0th power, Nathan?
1.
Is 1. So is 560 divided by 1 560? Okay. 560 divided by 10 to the first power is 56. How did they get 56? What did they do? Siddharth?
Well, 10 to the first power is the same thing as 10. And previously we learned that 560 divided by 10 is also 56.
Ah, and I noticed that the exponent here is 1. And I've noticed that how many spaces did the decimal point move? 1, okay. 560 to the second power, which we know is 100, which is the same as multiplying by 100th. How many spaces did the decimal point move?
2.
2 spaces to the left. Huh. The exponent is 2, and then the decimal point moved 2 spaces. Here the exponent was 1, and the decimal point moved 1 space. Here the exponent was 0. Did the decimal point move at all?
No.
It moved 0 spaces. Huh. So following this same pattern, 560 divided by 10 to the 3rd power, how many spaces to the left should my decimal point move? How many spaces should it move? Colin?
It should move 3 spaces to the left.
So my answer was 560 originally, and because the exponent is 3, following this pattern, I think that the decimal point should move 1, 2, 3 spaces to the left. Is that the answer we expected? Yeah. Each divisor, number 2 says, each divisor, or power of 10, is 10 times the divisor before it, right? How do the quotients compare? When my divisor, which is this row right here, is getting 10 times bigger each time, right? Is 10 times bigger than 1?
Yeah.
Is 100 10 times bigger than 10? Yeah. Is 1,000 10 times bigger than 100? Yeah. So this is getting 10 times bigger each time. What's happening to my quotient, or to my answer? What's happening when I divide by something 10 times bigger? What's happening to the quotient? Karan? It is getting smaller. How much smaller? Devana? It's getting 10 times smaller. I start with 560, then 56, then 5 and 6/10, then 5600. It's getting 10 times smaller. As I divide by something 10 times bigger, does it make sense that my answer would get 10 times smaller? Yeah.